Hey YouTube, Tech Freckle here again. Let's get started on the course. Welcome to the Full Stack Engineer. See what you'll learn in the Full Stack Engineer career path. Welcome to the Full Stack Engineer career path. In this path, you will encounter all of the major technologies that a full stack developer should know. You will gain a foundation in JavaScript programming, be able to use front-end technologies like HTML, CSS, React, and build secure backends with Node, Express, and Postgres SQL. We'll also make sure to prepare you for the infamous technical interviews you'll encounter once you begin your job hunt. Learning objectives. After this path, you will be able to set up your own dev environment and version control your work with GitHub, write client-side and server-side JavaScript code, create static responsive websites with HTML, CSS, use the popular React front-end framework along with Redux, build Node Express backends, design and build PostgreSQL databases. Connect a front end to a back end for a full stack PERN application. Implement best security practices to prevent attacks. Pass a JavaScript whiteboard interview. Cool. Syllabus pages. We've created two types of syllabus pages to help you guide through this journey. You've already navigated to this article from the first type, the career path syllabus. You can use career path syllabus to see all topics you'll need to know to become a full stack engineer or as a tracker for what you've learned and will continue to learn. And from there, you can click on one of the topics listed on the right to access the second type of syllabus, the unit syllabus. Okay. Unit syllabus is your go-to guide to your current unit. Each unit is a major topic that we teach using smaller chunks of content, and each unit syllabus contains expendable, collapsible lists of all of those lessons, projects, and other content. For example, in our fundamentals of HTML unit, we include a lesson on basic HTML syntax and practice content via a quiz and a project. We recommend looking at your current unit syllabus before you start coding for the day. Okay, pro tip. Click here to visit the syllabus for the unit you're in right now, and then click the Welcome to the Full Stack Engineer Path button to get back to this page. Okay. Projects. You will demonstrate your knowledge in several portfolio projects that exist throughout the career path. Portfolio projects are projects that you build on your own computer following a set of requirements. Each one will be unique to your personal vision and set of interests. You can complete the portfolio projects in either in parallel with or after taking the prerequisite content. It's up to you. Here's a preview of the projects featured in this path. Mixed messages. Build a Node.js console app that generates random messages each time a user runs the program, and version your project with Git/GitHub. Personal portfolio project. Use HTML, CSS, and GitHub pages to build a personal portfolio site, a static website where you can share your other projects. Reddit client. Interesting. Use JavaScript, React, Redux, and Reddit API. Build an online form containing real-life data. That's cool. E-commerce site, 2 parts. Over the course of 2 parts, build a full-stack web app where users can purchase projects using the PERN stack. How this is pronounced. Postgres, SQL, Express, React, Node. Open-end project. Use everything you've learned in the path to build an app of your choosing. That'll be interesting. Certification exams. We've added exams to help you assess your proficiency as you build towards job-ready skills. Here's how they work. You'll find exams on your full stack career path syllabus page at the end of each section. Each exam assesses your knowledge of the concepts and technologies learned within the section. Exams help verify your proficiency so you can feel confident in your abilities as you build toward a new career. Each exam is 2 parts. The first is multiple choice and fill in the blank, and the second is coding questions when applicable to the material. Otherwise, you'll encounter additional multiple choice and fill in the blank questions. Score at least 70% on both parts of the exam to pass. If you don't pass, no worries. You can retake exams once every 24 hours. No problem. Taking or passing exams is not required to complete the path, and exams do not factor into your progress percentage. However, exams must be completed and passed to earn your Codecademy professional certification. That means you can now skip past content you are already familiar with and still earn a Codecademy professional certification. That's cool. I probably will not skip any content, just as a refresher. Curated content through this path. You may see some items that aren't made by the Codecademy team. We've included these to ensure that you'll learn all the topics you need to get your career started. Though we didn't write them, We've vetted them ourselves for technical accuracy and good teaching practices. When possible, we've written relevant assessments so you can check your understanding back on our platform. Updates: since we strive to bring you the best and most up-to-date content, we will periodically update the materials in this path. For smaller updates, we'll be communicating changes via the web development changelog, which features updates and bug fixes across all web development content. For larger changes, we'll write a blog post detailing the extent of those changes and how they impact the syllabi. If you're enrolled in this path, we'll send a notification each time there's been an update so you know exactly what's changed. We're excited for you to begin your journey. Me too. Let's go. This is slow today. Helpful resources. In order to successfully take part in your learning journey, we've provided you with a set of resources. Congratulations on enrolling in the full stack engineer career path. We're excited that you're here to help you during your learning journey. We're sharing with you a set of resources. These resources include popular developer resources on the web, as well as recommended optional books can be used to supplement our Codecademy content. Popular developer resources. As you go through the path, we'll suggest certain resources for you to use, like articles, videos, tutorials, and documentation. Here are some additional resources that are considered groundbreaking, significant, or classics in the industry that will help you through your path. Okay. Go ahead and bookmark these resources. You won't need them now, but they'll be useful to reference and use as you go through the path. Optional recommended books. Codecademy prides itself on its interactive lessons, but sometimes it's useful to have a couple books on hand. The books featured in this path are considered classics in the industry, and many Codecademy learners and employees have found them useful. While the books list are recommended and will help you on your coding journey, purchasing and reading them is optional. The content covers the same topics that you'll find in your own lessons, but may be useful for those who want another explanation, perspective, or other opportunities for practice. Best of luck. All right, let's go. Introduction. Overview of web development. So we will be learning in the Overview Web Development Unit. The goal of this unit is to introduce you to the field of web development software engineering before diving into the technical parts of the track. After this unit, you'll be able to describe on a broad level how the internet works, identify different languages used for web development, define what programming is, summarize what a software engineer does in their job, explain the difference between front-end and back-end engineering and full stack. Learning is social. Whatever you're working on, be sure to connect with the Codecademy community in the forums. Remember to check in with the community regularly, including for things like asking for code reviews on your project work and providing code reviews to others in the projects category, which can help to reinforce what you've learned. Okay. Overview of the internet. Hello, internet. It is nearly impossible to overstate how much the internet has changed how we consume information and communicate with one another. More than 4 billion people around the world are internet users, and the total number of websites on the World Wide Web is nearing 2 billion. That's crazy. Despite the presence of the internet in our lives, very few internet users understand how it works. You don't need to be an engineer to benefit from understanding how the internet works. However, understanding the internet's infrastructure will help you decide if learning web development is right for you. In this lesson, you will learn how the internet works behind the scenes. After finishing this lesson, you'll be able to answer the questions like, how is data sent from one computer to another? What is the relationship between a browser and a server? How is code turned into the experience that users see in their browsers? How is the web and web development changed from its invention to today? By the end of the lesson, you will have the knowledge that you need to collaborate more effectively with engineers and jump into your own career path or your own career in web development. Check out the graph on the right. It shows the number of websites on the internet since 2000. When you're ready, move to the next exercise. This is crazy. What percentage of these is actually like legitimate websites versus just like complete garbage trash, like spam sites, domain buying websites, crap like that? It'd be interesting statistics to see. The ever expanding network. So, how did the internet start? In 1969, the United States Department of Defense funded the creation of ARPANET, a precursor network to the internet. ARPANET stands for Advanced Research Projects Agency Network. ARPANET connected supercomputing centers run by government agencies and universities. These institutions wanted to connect their individual networks for large-scale information transfer. However, many of them followed different standards and technical implementations. In the 1970s, the Transmission Control Protocol and Internet Protocol, otherwise known as TCP/IP, were created to provide standards around the transfer of data that would allow these early networks to communicate with each other. TCP/IP was researched and specified throughout the 1970s and adopted in the early 1980s as different networks adopted TCP/IP. The interconnected global network of networks that is today known as the Internet was formed. Check out the map of early ARPANET supercomputers when you're ready. Move to the next exercise. Okay, yeah, government and universities right on. World Wide Web. While people today often use the terms Internet and World Wide Web interchangeably, they actually refer to quite different things. The Internet refers to the actual network of connected computing devices. Although the Internet was around in the 1980s, there was not an intuitive way for most people to browse the Internet. The Internet just sent messages produced by one computer and presented them on to another computer. Engagement with the Internet changed in 1989 when Tim Berners-Lee invented the World Wide Web. The World Wide Web is a collection of interlinked websites and other web resources. The World Wide Web, in combination with the rise of web browsers in the 1990s, introduced a user-friendly interface that enabled users to browse multimedia content and interact with other users. The invention of the World Wide Web led to the use of the Internet in wider society through the 1990s and the creation of a variety of websites that are still in use today. The diagram to the right demonstrates how different pages on the World Wide Web are linked to one another. Move to the next exercise when you're ready to continue. This is this is really basic overview. Browsers and servers. As we've seen, the Internet is a network that links computer devices worldwide, enabling people to share information with one another despite vast distances. How is information sent from one device to another? One way of understanding this process is to look at the client-server model. In this model, the client refers to the user's device or program that is making a request for data. A client can be a browser application running on a user's laptop, smartphone, or tablet. The server is the device or program in that network that waits for incoming requests and sends back data. This might be an in-house server, a rented server, or a data center or cloud server. At Codecademy, we have servers that store lesson data, and our servers are sending this lesson data to your client device. Watch the video, learn about the importance of browser and servers, then move to the next exercise, and you're ready to proceed. I am not going to watch this. If you can, it looks like it's on Codecademy's page. Let's just skip to the next thing. 404 status code. Let's take a deeper dive into the client-server model through exploring a part of HTTP that you've probably seen before, HTTP status codes. When a server responds to a client, the server specifies a status code as a part of a response. Status codes indicate whether or not the HTTP request was successfully completed and if there was an error. They contain some information about the type of error that happened. The status code helps the browser know how to handle the data that was sent back in the response. Review the HTTP status code below and see if any of them seem familiar. Code. Explanation 200 is okay. Request is exceeded. 301 moved permanently. This resource has been moved and the client is being redirected. 404 not found. Requested resource was not found. In 500 internal server error. The server encountered an unexpected error. Okay. The browser is currently displaying a website that Alex has created to show photos and descriptions of her pets. If you click on the links for dogs or cats, you can see more information about Alex's dogs and cats. Next, click on the file in the upper left corner of the text editor. You'll see the different HTML files that the server is ready to send to the browser whenever those links are clicked. These HTML files are corresponded to the different web pages and are displayed in the browser. When the dogs link is clicked, the server will send the dogs HTML files to the client. Try out the dogs and cats links now. Yay. And let's guess turtles is 404. Yeah. Okay. Let's create a 404 status response by making a request for a non-existent resource. Alex hasn't built a web page to list her turtles. Click on the link for turtles to see how the browser display the 404 status code. Okay. How do browsers work? So far, we've seen how a single request and response are handled between a client and a server, but most of the time, our devices aren't making a single request. Every time we load a web page, our device sends a request for each file that makes up that page. So even when we're just loading one web page, that page can make multiple requests in order to retrieve different pieces of content, like images. So how does this process work when we're making multiple requests simultaneously? All of the following steps happen in a split second. When a user types in a URL and presses enter, the server processes the request and sends the HTML file back to the client. HTML files hold the content of a website, and they also contain links for any additional assets or code that are needed to display the site properly. The browser will begin to search for elements in the HTML file, and it will start to make additional HTTP requests for any other external resources used by the HTML file. This often includes one or more CSS style sheets. CSS stands for Cascading Style Sheets. CSS creates the style and layout of a web page. The browser will request the CSS style sheet, and when the server sends it back, the browser analyzes the CSS and starts applying the visual styles to the content of the site. The request response cycle also sends website assets like images and videos from the server to the browser. If these files are large, there might even be a noticeable delay before they are rendered by the browser. One or more JavaScript files. The JavaScript makes the web page interactive. This programming language functions as the behavior of the web page. A web page that does not use JavaScript is known as a static web page. In most modern browsers, these additional requests are made in parallel. This means that these requests are initiated at the same time, and the browser does not wait to receive one resource before requesting the next resource. All of the resources are typically displayed as soon as possible. The HTML be displayed even if some of the other assets have not been received by the browser. Voila, the user can now interact with the website that they requested to see. This whole process typically happens in about a second or less, depending on the speed of the user's connection, the size of the websites, and even physical distance between the browser and the server. Okay, the animation to the right shows the different languages that work together to display a web page. When you're ready, move on to the next exercise. All right, easy peasy. Web 2.0. Now that we've covered some of the basics of how the internet works, let's check out some trends that are fundamental to the emergence of modern web development and modern JavaScript. The earliest static websites were composed of text, images, and links, with very little interactivity beyond browsing from one page to another. These websites are called static, which means lacking in movement because they do not change based on user behavior. As internet connection speeds and website technologies progressed, more complex interactions became possible on the web. A collection of advances in the early 2000s created a cluster of web applications that are often called Web 2.0. In comparison to early static websites, Web 2.0 applications are often defined by providing a dynamic user experience by offering content that responds to user input without forcing the page to reload. In the early web, user input would typically take the user to a new page, and they would have to wait for the new page to load. In Web 2.0, websites could just update selected regions of the page, avoiding the interruption caused by reloading. Emphasizing user-generated content and social sharing. In the early web, content was generally authored by a single source. The rise of blogging, social media, and wikis in Web 2.0 meant that users could generate content and share it with their friends. There were important technical advances that enabled each of these advances in the user interface of the internet. For example, jQuery was the first JavaScript framework that could fetch data while the web page is running. Okay. The rise of web frameworks that connect to databases like Spring, Django, and Ruby on Rails enable user-generated content to effectively be created, stored, and displayed. What are the differences between Web 1 and 2? The answers are in the screenshots on the left. The Web 1.0 page is static. It does not respond to user behavior, and the content is the same for all users. On the right, the Web 2.0 page is interactive. You can like and comment on the page, dynamic. The time since posting, currently 12 hours, updates without reloading the whole page, allows social interaction. A lot of friends like this image. Move to the next exercise when you're ready to continue. Yeah, you say I can't interact with it, but makes sense. Current internet trends. The rise of internet connected smartphones has profoundly changed how users interact with the internet. Mobile internet traffic now accounts for more than half of all internet traffic, and web development practices have evolved in order to provide a good user experience regardless of device type. Well, it makes sense. Everyone's got a phone, basically. Responsive web design. The rise of responsive web design has changed how websites are built. Responsive web design was enabled by additions to the CSS language like media queries and relative units. These additions allow the presentation of websites to adjust based on the size of the window in which they are displayed. Mobile applications and devices. The rise of internet-connected mobile applications has changed the way that we think about browsing the internet. Users accessing the internet on smartphones are likely to spend much more time with specific applications rather than using their phone's browser. The most mobile applications are internet connected. They are not part of the Wide Web. The web is built out of links, whereas mobile applications are designed to keep their users' attention. If you want to learn about mobile development, web development is a great place to start. While the majority of mobile applications are built in programming languages like Swift or iOS, it is increasingly common to see developers using JavaScript frameworks to build new apps. Well, that's good. Check out the basic responsive website shown here. Try resizing the screen. You'll notice the same font size adjusting as the screen width changes. Move to the next exercise when you're ready to proceed. Okay, so I don't know if this is going to work 100% because I am recording the window itself, but review. Congratulations, you should now have a general understanding of how the internet works, including the growth of the internet as a network, the differences between the internet and the World Wide Web, the relationship between browsers and servers, HTTP status codes like 404 not found, big trends in web development from static websites to Web 2.0 and the rise of mobile. If you work with engineers, this information will help you talk about websites and web applications at a more technical level, or if you're interested in becoming a web developer yourself, you have the important context to start building building your own website and web application. Cool. Up next, let's see.